Hello student, this is SAVITA PAWAR. Welcome to my channel Get the Math. In this video we are going to see the solutions for exercise 8.1 of lesson 8 quadrilaterals. So let us first have some explanation. Now here in your earlier classes you have studied about collinear points and non-collinear points. So the points which lie on a single line segment or a ray or a line are called as a collinear points. Otherwise they are called as non-collinear points, such as this point in a triangle. So when three of the non-collinear points are joined together by line segments, then it is called as a triangle. So these are non-collinear points. Okay. So what are polygons now? A polygon is a simple closed curve made up of only line segments. Then those figures are called as polygons. Then they are further given some names, such as if it is 3 line segment, then it is triangle. If it is 4 line segments, that is joining the 4 non-collinear points, then it becomes a quadrilateral. Here quadrilateral are of 2 types, convex and concave. The difference between convex and concave polygon lies in the measure of the angles to be convex. All of these interior angles must be less than 180, then only it is convex, otherwise it is concave. If the interior angle is more than 180, then it is concave. So in your syllabus it is all about the convex quadrilaterals. So what is a quadrilateral? The definition for quadrilateral is, if no 3 points out of 4 are collinear, we obtain a closed figure with 4 sides is called as a quadrilateral. So a quadrilateral has 4 sides, 4 angles and 4 vertices. These are 4 sides, 4 angles and 4 vertices. Angle sum property of quadrilateral is, that is sum of all the angles of the quadrilateral is equal to 360 degree. There are different type of quadrilaterals. I have shown here a tree of the quadrilaterals. Quadrilateral is divided into parallelogram, kite and trapezium. These are the figures of parallelogram, kite and trapezium. Okay. Further we are going to see about the properties of all these figures or all these quadrilaterals. Parallelogram is then further divided into rectangle and rhombus, and rectangle is further elaborated as square, kite as arrowhead and trapezium here as isosceles trapezium. Let us see about the properties of parallelogram of the following quadrilaterals. First one is the parallelogram. The diagonal of a parallelogram divided into 2 congruent triangles. Suppose if you draw PR in a quadrilateral PQRS, then it will divide the parallelogram into 2 congruent triangles. Or SQ, if you draw SQ, then it will divide into these 2 congruent triangles. Diagonals of parallelogram bisect each other. These are the diagonals of parallelogram. They are not of same length, but they bisect each other. That is, they divide it into 2 equal halves. That is, this is the midpoint. Opposite sides of quadrilateral are of equal length. They are congruent. SR is equal to PQ and PS equal to RQ. And opposite angles are also congruent. That is, P equal to R and S equal to Q. And adjacent angles, this one S and P or SR and so on, these adjacent angles are supplementary. That is, if you add these 2 angles, it will be equal to 180 degree. That means they are co-interior angles. Okay. Second quadrilateral is rectangle. Its properties are, all the angles of rectangle are equal to 90 degree. Opposite sides are parallel and they are equal in length also. Diagonals, they are of equal length, that is congruent and bisect each other. And every rectangle is a parallelogram with at least one angle as 90 degree. So rectangle is a form of a parallelogram. Then comes rhombus. All sides of rhombus are congruent. Diagonals are perpendicular bisector of each other, that is, they divided into equal half and also at 90 degree. Each diagonal is angle bisector of the opposite angles. So this, if suppose you consider DF here, DF is the angle bisector of angle D and angle F also. That is, it divides the angle into two equal halves. And every rhombus of a parallelogram is a parallelogram and a kite with all the sides of equal length. So rhombus is a form of a parallelogram and also a kite. Properties of square are: all sides of the square are equal in length, all angles are 90 degree, opposite sides are parallel and or of equal length, diagonals of square are equal in length, bisect each other and also at 90 degree. So all of the properties above of the diagonal that are included in square. Diagonals of square bisect its right angle, that is, they also bisect its right angle, that is the vertices. Properties of kite: adjacent sides of the kite are equal in length, that is, AD is equal to DC and AB will be equal to CB. Diagonals of kite are perpendicular bisector to each other, that is, they bisect each other at 90 degree, and angle between the unequal sides, that is angle A and angle C, are equal. Then properties of trapezium are, this is a trapezium here. Now one pair of opposite side is parallel, that is AB is parallel to CD. So if the other pair is of the same length, that is AD, if AD is equal to BC, then this type of trapezium is called as isosceles trapezium, and if AD is not equal to BC, then it is only called as a trapezium. In isosceles trapezium, the diagonals are congruent, that is, they are of equal length and bisect each other. Okay. So these are all the properties of different type of quadrilaterals. You have to remember these properties to solve the further exercise. Now let us start with exercise 8.1. So now the solutions of this exercise are quite lengthy. So some of them I have already solved, but I will explain them all. My videos may be lengthy, but they are benefactory to you, as it will be no longer needed for you to search hither and thither for the solution of the next sum. That all the sums of that particular exercise and its explanation you will get in one go, which is time saving. Okay. So do like, share and subscribe my channel, Get the Math, and press the bell button. This is your question number 1 here. The angles of quadrilateral are in the ratio 3:5:9:13. Find all the angles of the quadrilateral. So this is, if the figure is not given, you have to draw the figure by yourself. So let this be the quadrilateral with ABCD as vertices, and then the ratio of these vertices is given as 3:5:9:13. So whenever ratio is given, you have to multiply it with the sum of the variable. So let that be x here. So angle A equal to 3x, angle B is 5x, C is 9x and D is 13x. Add all the angles of that quadrilateral, that will be equal to 360, as sum of the angles of quadrilateral is 360. Then if you add this, the total will be here 30x. So this is 30x equal to 360. Okay, so x will be equal to 360 by 30. You will get it as 12. So find each of the angles here. So A will be equal to 36 degrees, B equal to 60 degrees, C is 108 degrees, and this will be 156 degrees. Okay. So this is the way to solve question 1. Second question is, if the diagonals of parallelogram are equal, so it is given as the parallelograms are equal, that is AC is equal to BD here, that is in the given, then show that it is a rectangle. Now some of the questions here are prove the following. So you have to write here given, to prove and prove. So ABCD is a parallelogram given where AC is equal to BD. You have to show that ABCD is a rectangle. Now here we are going to consider the triangle ABC and BAD. So you have to prove these two triangles are congruent. So as you know, we have to write 3 things out of 6 to prove that the two triangles are congruent. You have seen the congruency in the congruency lesson. So from triangle this now BC is equal to AD. So this is BC equal to AD. The reason is, you have to write the reasons too. Opposite sides of parallelogram. This is the short form for parallelogram I am writing here. And then second point is here, that is given AC equal to BD, that is diagonals. So that is given. And the third one from the figure, you can see that AB is common for both the triangles. So AB is equal to AB, that is common, and therefore triangle ABC is congruent to triangle BAD by SSS congruency. After writing congruency, you have to write the CPCT. So we will say that angle ABC, this angle and this angle are equal. Therefore angle ABC will be equal to angle BAD, that will be your CPCT, that is corresponding parts of congruent triangles. The remaining parts are automatically equal if the two triangles are congruent to each other. Now, but in this case you can see that these two angles are co-interior angles. So therefore, that is, but angle ABC plus angle BAD is equal to 180 degrees. The reason is co-interior angles. Okay. So now, just now we have proved that these two angles are equal. So in place of these two, we can write any one angle. Suppose I will be writing here that ABC plus angle ABC equal to 180. So 2 times angle ABC equal to 180, which implies angle ABC is 180 by 2, that is 90 degree. Okay. So we have proved that ABC equal to 90 degree, and therefore since the two, now as we have seen above that angle ABC is equal to angle BAD, so both will be equal to 90 degrees, and therefore you have to write the statement as ABCD is a parallelogram with one of its angle which is equal to 90 degree will be a rectangle, and therefore ABCD is a rectangle, hence proved. Okay. So we have proved that the given parallelogram is a rectangle. Question 3 is, show that if the diagonals of quadrilateral bisect each other at right angles, then it is a rhombus. So you have to prove that this is the diagonals of a quadrilateral bisect each other at 90 degree, and you have to prove that it is a rhombus. So ABCD is a quadrilateral, AO equal to CO, BO equal to DO. It is bisecting, so these are equal here. You can see that is AO equal to CO and DO equal to BO, and this angle is equal to 90 degree. We have to prove that ABCD is a rhombus. So we will consider these two adjacent triangles from the given figure. I have split the figure into parts so as you can get it in an easy way. So now you have to write the congruency between these two triangles. As you can see from the figure here, that from triangle AOB and AOD, the things that are equal are OB equal to OD, OB is equal to OD, that is given above. You can see it is here. So it is given. then angle AOB is equal to angle AOD, which is equal to 90 degree, this one. And the third one is AO equal to AO, that is common. Therefore, the given triangles, that is AOB, is congruent to triangle AOD by SAS. Okay, and here now you have to write the CPCT. Therefore, it becomes that AB will be equal to AD, that I have shown in pink color. AB is equal to AD, that will be your CPCT. Now we have proved that two of the adjacent sides are equal. Now similarly, by taking the next adjacent triangle, we can prove the other sides of this quadrilateral are equal. So we will writing here similarly. There is no need to prove, just write similarly. AB will be equal to BC and BC is equal to CD. Therefore, all the four sides of quadrilateral ABCD are equal, and therefore ABCD is a rhombus. Now rhombus property of rhombus, as you have seen above, that the diagonals are perpendicular also, perpendicular bisector, and all the sides are equal. Therefore it is a rhombus. So that is the reason that you should remember all the properties that I have shown above. Question 4th is, show that the diagonals of a square are equal and bisect each other at right angles. So this is a square given. Now you know in square all the sides are equal. The diagonals are perpendicular bisector. So COD, this angle will be equal to 90 degree here. So this one will be 90 degree. Okay. And these are the bisectors. So prove that. Now we will consider triangle BAD again, that we have seen above. BAD and ABC. So AD will be equal to BC. BAD angle, this angle BAD equal to ABC, that is 90 degree, and AB is common here, and therefore triangle BAD is congruent to triangle ABC by SAS, and therefore its CPCT will be BD here, this one that I have shown here, curvy mark, that is BD is equal to CA or AC. Then consider the next triangle AOB, this one AOB and COD here. Here you can see angle A, this one OAB will be equal to OCD and OBA will be equal to ODC, since they are alternate angles, this one and this one, and AB is equal to CD, and therefore these two triangles are congruent to each other by ASA, angle side angle, and therefore its CPCT will be AO or OA is equal to OC and OD is equal to OB, that is the CPCT. Now I have shown the figure, I have split the figure and also shown the different color codes so as you can get the point easily. Okay, let us consider the next triangle now. AOB and AOD here. So OB is equal to OD, AB will be equal to AD here, and OA is common or AO is common, and therefore these two triangles are congruent by SSS, and therefore the CPCT is AOB is equal to AOD. This angle is equal to this angle. Okay. Now you can see these two angles are on a straight line. So it is linear pair. So since they are equal, you can write 2 times AOB equal to 180. So AOB is equal to 90. So if this is 90, so this is also 90. And therefore the diagonals of a square are equal and bisect each other at right angles. So we have proved that the diagonals are equal and they bisect each other at right angles. show that the diagonals of quadrilateral are equal and bisect each other at right angles, then it is a square. Now this is the converse of question 4. So ABCD here is a quadrilateral such that AC is equal to BD and AO equal to CO and BO equal to DO and angle COD is 90 degrees. So you have to prove that ABCD is a square. So if the diagonals of quadrilateral bisect each other at right angle, then it can be a rhombus too. Now in rhombus all the sides are equal, that is your equation number 1 here. So consider these two triangles from the figure, that is BAD and ABC. Okay, so write all the three given properties that are equal here. So it will be AD is equal to BC, then BD equal to AC, that is also given, and this is here proved above as these are the sides of a rhombus. And the next one is AB equal to AB, that is common, this is common, and therefore triangle BAD is congruent to triangle ABC by SSS axiom, and therefore its CPCT is here now. This angle will be equal to this angle, that is angle BAD is equal to angle ABC, that is the CPCT. But it's the same thing you have to write here, that angle BAD plus angle ABC is equal to 180. The reason is co-interior angles. Therefore 2 times angle BAD equal to 180. You can substitute BAD in place of ABC and you will get this. So angle BAD is 180 by 2, that is equal to 90 degree, and therefore angle ABC will also be equal to 90 degrees, and hence if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. So question 6, diagonal AC of a parallelogram ABCD bisects angle A, show that it also bisects angle C and ABCD is a rhombus. So here diagonal AC bisects angle A, so here DAC is equal to BAC, these two angles are equal. You have to show that these two angles are also equal. So I have shown the angles by color coding here. So by only visualizing you can see which angle is equal to what angle. So here you can say that these two angles are equal, but DAC is equal to BCA because alternate angles, and similarly here DCA is equal to this angle BAC, that is also alternate angles, but these two are equal and therefore these two are also equal. Okay, so this is the way to prove. Now we will write in sentence, that is angle DAC is equal to angle BAC from equation 1 that we have taken. So this is given. Then angle DAC is equal to angle BCA, that is your equation number 2, because alternate angles. And the third one is angle BAC is equal to angle ACD. This is your third equation, that is also alternate angles, and therefore triangle ADC will be congruent to triangle ABC by angle axiom. Okay, and therefore from equation 1, 2 and 3 we can get that angle ACD is equal to angle BCA, that will be your equation number 4th, and this proves that hence diagonal AC also bisects angle C. Okay, that is the first question we have proved. Now the second one that we have to prove it as a rhombus here. Now to prove that it is a rhombus, we have to prove that the sides are equal. Now from equation, since this is equal to this, and then we have proved that this is also equal to this, so all these angles are equal. Now suppose if you guess here that this was 30 degrees and this is also 30 degrees, so as this is alternate, so this will be 30, and as this is alternate, so this will be 30, so these two are also equal, so it becomes an isosceles triangle. Now in triangle, this one we are considering ADC here, so this one angle DAC is equal to angle DCA from above. Okay, so in triangle ADC here, which is an isosceles triangle, so angle ACD or DCA is equal to angle DAC, that is proved above, and AD is equal to CD. These are opposite sides to equal angles. Now as you know, in isosceles triangle, if the base angles are equal, then the side opposite to it are also equal. So hence, if this is 30, this is 30, then these two sides will be equal. So AD equal to CD. And therefore, we can say that a parallelogram whose adjacent sides are equal is a rhombus. And therefore ABCD is a rhombus. Okay, so this is how you have to prove that the given parallelogram is a rhombus. Question 7 here is ABCD is a rhombus. Now this is a given figure that ABCD is a rhombus, and it shows that its diagonal AC bisects A as well as C, and diagonal BD also bisects B as well as D. So this is the converse of question 6 here. So ABCD is a rhombus, so all sides are equal, that will be equation 1, and these are the two proof. Now consider triangle ADC here. Here AD is equal to CD because it is a rhombus. So this becomes an isosceles triangle. Now we will consider the converse of isosceles triangle, that since sides are equal, therefore the base angles will also be equal, therefore 1 will be equal to 3 here. Okay, that is your equation number 2. But we know that 3 is equal to 2 because alternate angles, and therefore 1 will be equal to 2. Okay, now just now that I have shown above, as this will be 30, this will also be 30 because it is an isosceles triangle. Okay, but this will be 30, so this is also 30 since they are alternate angles, and therefore these two are equal, so 1 will be equal to 2 here. But we know that 1 be equal to 4, 1 is also equal to 4, that this angle equal to this angle, 1 is also equal to 4, that is alternate angles again, and therefore 3 is also equal to 4. Okay, all the angles are equal to 30 now, that is equal, and therefore from all the questions above, or from 4 and 6, we can say that AC bisects angle A as well as angle C, since you get all the angles as equal to 30 if you consider. Now similarly in this case, we have to take BD as a diagonal, and the same process I have taken 5, 6, 7, 8 as the angles. So from 1 we can say that AD is equal to AB, it is a rhombus, sides of rhombus, and therefore 5 and 7 will be equal. Okay, that is the base angles of isosceles triangles, but phi equal to 8 since it is an alternate angle, and 7 is also equal to 6 because of alternate angles, and therefore 7 will be equal to 8 here. Okay, so the same process that we did above, and therefore we can say that BD bisects angle B as well as angle D here. Question 8. ABCD is a rectangle in which diagonal AC bisects AC as well as C, A as well as C, and show that it is a square, and diagonal BD bisects B as well as D. So here it is given that ABCD is a rectangle and this diagonal bisects A as well as C. Okay, so 1 equal to A as well as C it is bisecting. Okay, 1 is equal to 2 here and 3 is equal to 4, that is given. You have to prove that it is a rhombus, and B, if you draw BD, then it bisects B as well as D. Now same thing, 1 equal to 2 given, but 1 is equal to 4 because alternate angles. Okay, and therefore 3 will be equal to 4, and therefore as 1 equal to 3, therefore 1 will be equal to 3. So 1 equal to 2 it is given, but 1 will be equal to 4 as alternate angles, and therefore 3 will be equal to 4, and therefore 1 will be equal to 3. Okay, so that is, we have taken equation 1, 2, 3. Now consider triangle ADC here. Here AD equal to CD. Okay, since 1 equal to 3, therefore AD will be equal to AC, and the rectangle whose adjacent sides are equal will be a square. As you know, all the angles of rectangle are 90 and also the sides are equal, therefore it becomes a square. That is the first proof. Now by drawing the square, you have to consider and drawing the BD diagonal. Now consider these angles 5, 6, 7, 8. As you have seen earlier, the same thing, AB equal to AD here, that is the sides of square. Therefore 7 will be equal to 5 here, but 5 is equal to 8 here because alternate angles, hence 7 will be equal to 8. But 7 is equal to 6 here again because of alternate angles, and therefore 5 will be equal to 6. Okay, and therefore we can say that BD bisects angle B as well as angle D. Most of the questions are similar and they have the process is repeated. In a parallelogram ABCD, 2 points P and Q, these are the 2 points P and Q are taken on the diagonal BD such that this DP is equal to BQ. You have to show all these things. So let us start. Now to prove, I have written only the numbers from the question, you have to note down the same thing. So now for the first proof, we have to consider this triangle that I have shown in pink color, ABD and BQC here, or CQB. So here DP, this one DP is equal to BQ, and angle ADP is equal to angle CBQ. This angle is equal to this angle, alternate angles, and AD is equal to BC, opposite sides of parallelogram. Therefore these two triangles are congruent by SAS, and therefore their CPT is AP. This one AP is equal to QC. That is the CPCT. That is equation number 1. And point number 2, that we have proved. Then point number 3 is, we have to consider these two triangles AQB and here CPD. Okay, here three things that are equal are QB is equal to DP, angle ABQ is equal to angle CDP, this angle is equal to this angle, alternate angles, and AB is equal to CD, that is opposite sides of parallelogram. Therefore these two triangles are congruent, and therefore AQ is equal to here CP. That is your equation number 2. Now from equation 1 and 2, you can say for quadrilateral AQCP as it is a parallelogram because opposite sides are equal. Here AQ is equal to CP and AP is equal to CQ. Therefore opposite sides are equal, and therefore it is a parallelogram. Hence proved. Question 10. ABCD is a parallelogram here, and AP and CQ are the perpendiculars drawn from A and C on the diagonal BD. We have to show that APB and CQD are congruent and AP is equal to CQ, that is the CPCT. So we are going to consider these two triangles here. So what are the equal things that you have to write? So it will be angle APB is equal to angle CQD, this CQD that is equal to 90 degree. This is 90 and this is also 90. Then angle ABP equal to angle CDQ. These are alternate angles. This angle and this angle, these are alternate angles, and AB is equal to CD. These are the opposite sides of parallelogram, and therefore triangle APB is congruent to triangle CQD by SAS, two sides and angle, okay, SAS, and therefore the CPCT becomes that AP is equal to CQ, that is the CPCT. That is your second point. So this was the first point to be proved and this is the second point. Okay. Question 11 is, in triangle ABC and DEF, the vertices have been joined here. So AB is equal to DE and it is parallel. BC is equal to EF and it is also parallel. Okay, so we have to prove that ABED is a parallelogram, BEFC is a parallelogram, and AD is parallel to CF and it is equal, and quadrilateral ACFD, it is also a parallelogram and it is AC is equal to DF, and triangle ABC is equal to congruent to triangle DEF. So these are the 6 things to be proved. So now let us consider first one, quadrilateral ABED. So ABED from this figure, here AB is equal to, this one it is given that AB is equal to DE and AB is parallel to DE and therefore ABED is a parallelogram. That is equation number 1. That is, hence it will be, we will write it as, since this is a parallelogram, so here AD will also be parallel to BE and AD will be equal to BE. Okay. Then consider the parallelogram which is at the base BEFC. Now in BEFC here, BC is equal to this one. BC is equal to EF. This one BC is equal to EF and it is also parallel. BC is parallel to this, therefore it is a parallelogram. Now since this is a parallelogram and therefore you can say that its opposite sides, these are also equal and parallel, and therefore this side will be equal and parallel to CF, that is BE is equal and parallel to CF. Now you can see that AD is equal and parallel to BE and BE is equal and parallel to CF, and therefore AD will be equal and parallel to CF. Therefore from 1, 2 and 3 we can write that. Now consider, so this is all that we have written here. AD is equal to CF and therefore ACDF is a parallelogram. Okay. Now consider the triangles where we have proved all the sides are equal. So AB is equal to EF, that is given, AC equal to DF, that we have proved above, and BC is equal to EF, that is also given, and therefore the two triangles are congruent by SSS. Question 12. Question 12 is, ABCD is a trapezium Here ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC. Okay, we have to prove that angle A equal to B, C is equal to D, ABC triangle is equal to BAD and diagonal AC and BD, that is equal. Okay, so for that figure you have to draw this figure in such a way that you have to extend AB to AE and extend C so that it cut at a point at E. Okay, so let this be CE now and this is AE. So AECD is a parallelogram and therefore AE will be parallel to this one. AE will be parallel to CD, okay, and AD will be parallel to CE. Now since it is a parallelogram, therefore opposite sides will be equal. Therefore AE will be equal to CD and AD will be equal to CE. Got it? But it is given in the question that AD is equal to BC. So if AD is equal to CE and AD equal to BC, therefore these two are also equal. CE equal to CB or BC. Now consider this triangle BCE. Now since these two sides are equal, therefore angle 3 will be equal to angle 4. As you know, for isosceles triangle, angles opposite to equal sides are equal here. Therefore 3 will be equal to 4. But you can see here 2 and 3 are linear pair. So it is equal to 180 degrees. 2 and 3 will be equal to 180 degrees. Therefore linear pair. But 1 and 4 here are co-interior angles. Okay, so that is also equal to 180 degree. That is your equation 5. Now since the right hand side is equal, so the left hand side will also be equal here. So equate that question 4 and 5. Okay, now since here 3 is equal to 4 from the triangle, therefore you can cut 3 and 4, that gives you angle 2 equal to angle 1. So angle 2 will be equal to angle 1. Now name of angle 2 is CBA will be equal to angle A here. Okay. The second point is you have to consider that ABCD is a trapezium where AB is parallel to CD. Therefore angle 1 will be equal to angle D. Since they are co-interior, not equal, angle 1 plus angle D equal to 180 and 2 plus C is also equal to 180, that is co-interior angles. So here also right hand side is equal, so left hand side will be equal. So you can cancel now 1 and 2 since we have proved it above that 1 is equal to 2. Therefore angle D will be equal to angle C. So these two angles are equal, that is D equal to angle C. Okay. Then consider draw these diagonals BD and AC. Now consider triangle ABC and triangle BAD here. So BC, this one BC is equal to AD, that is already given. Then ABC, this one angle, and BAD, this angle, these are two are equal. 1 equal to 2, that we have proved above. The same thing, and AB is common here. And therefore these two triangles are congruent and therefore AC will be equal to BD, that is the diagonal AC will be equal to diagonal BD by CPCT. Okay, that was the fourth point that we have to prove. So this is all about your exercise 8.1. If you have any query, drop it in the comment box. Do like, share and subscribe my channel. Get the math.